So far in this unit, we've covered three ideas around factoring. The first was looking for a common factor. And what that means was, is there something that we could divide all of these terms by? And because that's really what factoring is, it's just a form of division. Okay. The second idea was, are we left with the trinomial? Do we have a trinomial that we could factor into its two binomial factors, right? And the third was, we did difference of perfect squares, and that was something like when you ended up with x squared minus 9, and where's that missing middle term, okay? So those are the three ideas, but now what we have to do is mix them all together. We have to work with them all at the same time, and that's called usually factoring completely. And so the steps are pretty simple. Step one is we're always going to look for a common factor first. Okay, so that first thing that we learned, we're always going to do that step first. So I'm going to look up here and I can see, oh, I can divide all these by 2. So that'll work. Now this has n squared and this has an n, so I could divide both of these by an n, but this does not have an n, so I can't. There's no variable factor. I'm just going to divide by 2. So my common factor that I can take out is 2. And when I do that, when I divide everything by 2, if I divide that first term by 2, 2n squared divided by 2 is just n squared. 18 minus 18 divided by 2 is minus 9, and then nothing happens at the end. And then plus 40 divided by 2 is plus 20. So at this point, I've factored out my common factor. That's my first step. Now, I'm not going to do anything else with this right now, but my next step is to ask whether or not this is a trinomial or a difference of perfect squares that I can factor. And so we're going to do the same thing we've done every time for that is we look at the patterns. We know that what we're looking for is two binomials where the numbers multiply together to get 20 and they'll add together to get negative 9. So let's see what we can multiply together to get 20. I could do 1 times 20, but if I add that, I'll get 21. That's not going to work. I could do 2 times 10. If I add that together, that's going to get 12. That's not going to work. I could do 4 times 5, but if I add that together, I'll get 9. But now there's an issue though. I'll get positive 9, but I need a negative 9. But my other option is I can multiply a negative times a negative, and that would get me 20, right? Negative 4 times negative 5 equals positive 20. And negative 4 plus negative 5 equals negative 9. And so that's exactly what I'm looking for. And so those are my two numbers. My two numbers are going to be negative 4 and negative 5. So now I'm just going to write my brackets. Right? And I know I'm going to have n minus 4 and minus 5. And then don't forget my 2 I still had. Right? So I had my 2 out. I did factor that out from the first step. And then now I have my two binomial factors, and all three of these are factors of 2n squared minus 18n plus 40. And so that's what we mean by factored completely. Okay, let's do a couple more. The steps are the same. So first thing, is there a common factor? Is there something I can divide both of these by? Well, I could divide this by 2 and this by 2. So we're going to have the same first step here. I'm going to take out this common factor of 2. What's left? Divide that by 2, I get just x squared. Divide 18 by 2, I also have 9 in this case, okay? But I don't have a trinomial now. But what I do have is a difference of perfect squares, because x squared is x times x, right? And 9 is 3 times 3. So what you should remember in this is that I'm going to have still two binomials, but I'm going to have x plus 3 and x minus 3. Remember the two keys here. Both of them are 3s. That's how you multiply to get 9. One has to be plus and one has to be minus. And let's just pull out my two. Let's pull that down right here. But then let's show why this works, just as a refresher, right? Why does this work? Because what happens when we do this, I go x times x is x squared. X times negative 3 is minus 3x. Now watch what happens right here. Positive 3 times x is positive 3x. And so these right here are going to cancel out because you have a negative and a positive. That's why if the signs are different, but the magnitude is the same, they're both 3, but the signs are different, so they're going to cancel each other out. And that's why that middle term disappears. Now, 3 times negative 3 is negative 9, and that's how you get a minus. It's always going to be a minus, right, because you're multiplying a positive times a negative. So it's always going to be some perfect square, x squared, minus some other perfect square, 9. And that's exactly what we got, right? So that's how we checked. That worked. But so our factors are here, 2 times x plus 3 times x minus 3, and that is factored completely. And so this example is good because I just want to drive home that we're going to go through these steps, but there's not always going to be a common factor, right? We're always going to look for one. That's always the first step, look for a common factor. But there's no guarantee that there's going to be one, right? So I have k squared and a k, but I have no k in the third term, so I can't take out any variables. And, 6 and 8, I could divide both by 2, but there's only a 1k squared. The coefficient there is a 1. So there's no coefficient and there's no variable that I can factor out. So I can't do step 1, but we always have to look for it, okay? So just because we're doing that now doesn't mean it's always going to be the case. So in this case, I'm going to jump right to step 2, and I'm going to look to see, is this a trinomial? Yep. And so can I factor it? Okay, so let's look. Remember what we're looking for if we can factor a trinomial. We want to look for two numbers that multiply to 8, positive 8, and add to negative 6. So I always start over here with the multiplication. I can just make a list. I can do 1 times 8. If I do 1 times 8, that works, but if I do 1 plus 8, I get 9, so that's not going to work. So I could do 2 times 4, do 2 times 4, and now look, 2 plus 4 is 6, but our signs aren't correct. So I could do negatives, right? Because if I do negative 2 times negative 4, I get positive 8, which is exactly what we want. And if I do negative 2 plus negative 4, I get negative 6. And so that works for both. That gets us exactly what we want. So we know our two numbers are positive 8, negative 6. So all I need to do now is draw my binomials, put in my k's, plus 8, minus 6. That's it. And you are done. Okay? One last example. So again, we're looking for that common factor. That's always the first step. So you might have to check out a calculator if you're not sure, but I'm going to start with this 9, right? If I see, I'm going to see if the smallest number goes into all the other ones. And so it does. I can divide everything here by 9. I could divide that by 9. I could divide that by 9. I could divide that by 9. Now, I'm also going to look for variables, right? So I have 4 in this term, and 3 in that term, and 2 in that term. So I have at least 2 in each term. So I can factor out x squared. So x squared, x squared. And so I'm drawing it like this to kind of drive home that this is division, right? But the way we're going to write it is I'm going to take out my 9x squared, right? That's my common factor, my greatest common factor. And now, but what I'm going to get back in here in the trinomial is what I'm getting when I divide these terms. And that's why I drew it like that, because it's really what we're doing. By taking it out, what we mean is dividing by it. And that's the same as factoring. So 9 divided by 9, that cancels out. X to the 4th over x squared. Imagine that's 4 x's on top you're multiplying, 2 in the bottom, 2 are going to cross out. So you're just left with x squared. The other way to think about it is you're taking 2 away from 4. Okay, 54 divided by 9 is 6. X to the 3rd over x squared. You're taking 2 away from 3, so you have 1 left. And then again, 36 divided by 9 is, again, it's negative, so negative 4. And in this case, you're taking all the x's away, so there's no more x's. So we took out our common factor, and we're left with this trinomial. Now, that's step 1. Step 2, we still need to look for, can we factor this trinomial? And we're looking for exactly the same thing that we did in all of the other cases, which is there a number that multiplies to negative 4 and adds to negative 6? So we're going to start with the negative 4. I could do, 1 times 4, right? I could do 1 times 4. And, well, that's not going to work for a sign, right? I'd have to do maybe times negative 4 times 1. So that would work. I'd get negative 4, but that's not going to add up to 6. So that's not going to work. Well, what else could I do? I could do 2 times 2, right? So I could do 2 times, negative 2. If I do 2 times negative 2, that gets me negative 4. But that doesn't add to negative 6 either. So, and that's it. That's the only numbers you can multiply to get to 4 are 1 and 4 or 2 and 2. So in this case, we can't factor that trinomial. So just because that's what we normally do doesn't mean you always can. Okay, so sometimes, like in the last example, you can't find a common factor. In this case, we found a common factor, but we couldn't factor the trinomial. So we're always going to do the 2 steps, but I just want to drive home that sometimes you can't do one or the other. It's not always the case where you can do both of those steps.